Seametrics.
I'll go over here.
We'll be talking about flow meters, application, and accuracy.
Oh, go ahead. Yep. How bad was I?
Good job.
Yeah. Oh, yeah. I probably need to take this. Let me get my microphone here. He's got to forget this here.
No, but they're good mints anyway. We're happy to be here. My name is Katie England. I work for Seametrics. We're a water flow meter manufacturer out of Kent, Washington. And Paul Carlson, our applications engineer, joined me today. Between the two of us, if you guys have any questions regarding flow meters, we should be able to answer them, or hopefully we'll be able to address any questions you might have. What we're going to talk about today is just, I'm going to take you through a quick overview of flow meters. Most people today that are irrigating, they either have a flow meter or they will need to have a flow meter at some point. How many of you deal with flow meters right now? Okay, quite a few of you. All right. So there's so many choices out there when we look at flow meters, it almost becomes overwhelming. Seametrics has been around since 1990. We sell into all different types of markets, from industrial, municipal, irrigation, agriculture, food and beverage. The irrigation agriculture market's my passion. I've been dealing with flow meters in this market for almost 16 years. And we're just seeing the trend continue to grow and grow. You know, areas like California where they had that record drought going on, and we've got areas in Idaho that are starting to mandate metering. So it's, like I said, if you don't have a meter, it's probably coming down the road. So we'll go through some of these topics. If you have any questions as we move along, just feel free to interrupt me. We're just going to quickly look at flow meter fundamentals. What are they? Why do we use them? How do we pick one? How do they work? What different options are there? And then we're going to look at new trends in flow meters, where we see the direction of meters moving from mechanical to no moving parts meters. For those of you that have meters, you might be challenged with accuracy testing them. How do I know my meter is performing accurately? And then we'll just touch on remote monitoring of flow meters. So what is a flow meter? It's basically a device that measures the rate of flow and provides a visual output or some type of communication. Most meters you guys are probably familiar with. You drive up to it and you look at a screen on it, either a mechanical or a digital readout. It provides instantaneous flow rate. What's the current flow going through that meter right now? 1500 GPM, 2000 GPM. It might provide information on the flow direction. Most time it's forward flow. Now and then there's bidirectional flow. And most of them provide your totalized flow. That's usually the main purpose of a flow meter. How much total water have I used? A lot of times in irrigation, it's either in acre feet or acre inches is how we're measuring it. So we're either measuring it for a season, might be an annual basis. Some people check how often they're reading their meters, weekly, monthly. It just kind of just depends on what you're doing with that information or who needs the information. Why do we measure it? We're accomplishing something. Either, like I just touched on, the totalized information, we're either displaying that data and we need to control something, control the pump, control something at that site, or we're data logging. How much water are we flowing through a given period of time? Flow rate implies a unit of time, and then the total implies the total volume passed through the meter. So normally if you're looking at a flow meter, you've got rate and total on it. If you go to order a meter, that's what the dealer or the manufacturer is going to ask you. How do you want it to read? That's typically what they're asking you. Some meters are programmed at the factory level, and you can't change them in the field once you've purchased them. So if you order them totalizing in gallons, indicating in gallons per minute, that's what you get. You can't change it. Other meters, you can reprogram them in the field. You can't reset the total volume, but you can reprogram the units of measure. When you select a meter, it's really as simple as going through a checklist of what is the pipe size that the water's flowing through, what is your flow range. Most meters have a minimum and max flow range that they operate within. What is the media? In irrigation, it's typically just clean water. You might have a little bit of sediment in it, but it's usually well water. Temperature and pressure, is it ambient? What's your pressure? Typically it's under 150 PSI range when we're speccing a meter in irrigation. How much straight run pipe is available? Is it a horizontal or vertical installation? That impacts some technologies, others it does not. And do you need outputs on it? So some of the outputs that are common in irrigation are pulse. We're seeing more and more demand for a Modbus output. And then, and 4 to 20 is not quite as common, but we do see some of it in irrigation. What's the accuracy requirement? That's kind of a critical one to know, because as you're looking at what type of technology you're going to select, a lot of times when you're looking at price points on flow meters, the less accurate the meter, usually the less upfront costs it's going to be. Doesn't mean your overall cost of ownership is going to be less, but your upfront out-of-pocket costs could be less. And when we look at overall cost of ownership, what's the required maintenance on that type of technology that you've selected? So there's really just two things that I think about when I think about steering somebody towards a good flow meter choice for them. There's mechanical versus electromagnetic, and there is insertion versus inline, and that's pretty much it. And then you're going to find all of these different choices in those categories. So mechanical meters, they've been around for the longest. That's what a lot of people are familiar with. There's a lot of mechanical meters installed all around the country. And we see a picture of an example of a propeller style meter down in the left-hand corner. You can see that meter in different configurations. That meter's been around since the 1950s, and I don't think the design has really changed much since then. That's a mechanical propeller meter. Other types of mechanical meters are a turbine, multi-jet, paddle wheel. Again, these are moving parts meters. They used to cost quite a bit less upfront to purchase, not so much anymore. As electromagnetic meters have become more and more common, the demand of them has gone up, the price of them has come down. Mechanical meters require a longer straight run of pipe, and I'll get into that in just a few minutes on what that means, and than mag meters do. And mag meters have no moving parts. They install in a real small footprint. So if it's an old well and now you need to put a meter there and you don't have a lot of straight run pipe, mag meters are a good choice for that. Both insertion style and inline style, or otherwise called full bore meters, are available in mechanical or electromagnetic. So that's something to keep in mind. This is a full bore or inline flanged end meter. This is an insertion style meter. This happens to be a paddle wheel, but these are available with a magnet on the end as a insertion magnetic meter. So just something to keep in mind is you can get both styles. You can get both types of technologies, either inline or insertion style. Insertion style meters are obviously easier to install because you're not cutting a big section of your pipe out, welding mating flanges in, and adding the gaskets and maybe grounding rings and the bolts and everything to get that meter in line. So insertion meters are typically installed with either a saddle or a T, some type of a fitting that you're installing it into the pipe with. That's the advantage of an insertion meter, is the ease of installation. The disadvantage of them is they do require longer upstream, downstream pipe requirements, and they're less accurate than inline meters. The main reason they're less accurate than inline meters is because the manufacturer of an insertion meter, they don't own the pipe diameter that meter's being installed in. They don't calibrate the meter to that known diameter. So if there's sediment buildup in that pipe, there's all types of variables. How far is that meter being inserted in the pipe? Is it only measuring one point across? Is it multi-point? There's all types of variables with insertion meters. So as a rule, they're not as accurate as full bore inline meters. Inline meters are going to require more labor to install. The advantages are you can put them in extremely tight spaces. They are calibrated to a known accuracy at the manufacturer's lab. They're typically NIST traceable with that calibration report, so they're going to be just more accurate. This is just a snapshot of some different types of irrigation flow meters. So that top left-hand corner is the one, we have a meter example out here for you to see on the table. That is full bore flange gen. That is the most common meter that we sell into the irrigation market. It's, again, installs in tight spaces. We have an insertion mag meter. Those are very popular too if you don't need as high of an accuracy. They're very economical. And then for smaller line sizes, when you're looking at drip or real small line sizes, there's a 1 through 3 inch meter. These are just some examples of them. Those are, the ones you're looking at up here are all mag meters. Down in the left-hand corner, that is a meter that's typically used in chemigation and fertigation. You'll see those occasionally on different systems. And then data logging units, and then a remote totals. There's just there's so many different meter options out there, and there's so many different manufacturers out there. When you're selecting a meter, I already mentioned this, are both available as mechanical or electromagnetic. And here's just some examples of the left-hand corner is insertion electromagnetic. The center, that would be a full bore or inline electromagnetic. And the right is your larger size inline or full bore electromagnetic. There's paddle wheel meters, and that we have a paddle wheel meter here on display. And these are a pretty popular meter as well. Again, little less accurate, very economical. We sell a lot of those paddle wheel meters. They only have one moving part in them, and it's actually the bearing is a ruby jewel bearing. They're real durable. If it ever needs to be replaced, it pops out, pops back in. So paddle wheel meters are also a good option, but they're not as accurate as an inline meter. When I talk about an inline, or I'm sorry, an inline full bore meter, that's with all meter manufacturers. That's not unique to Seametrics. It's the technology. A full bore meter, inline full bore meter will always be more accurate than an insertion style meter. Whenever you're installing a meter, it's critical that you look at the quick start guide or the manual and you follow the proper installation guidelines. A lot of people will put a meter in line and then wonder why it's either reading erratic, they think maybe it's recording more flow than it should be or less flow than it should be. Usually it's recording more flow if it's installed inaccurately. The reason it's important to install them correctly is because these meters are manufactured so that to a specified accuracy based on that installation. So on full bore mag meters, your typical requirement is 2 pipe diameters upstream. What that means is you take your pipe size, if it's a 10-inch pipe, you multiply it by 2. So you'd want 20 inches of straight run pipe before the meter. So if it's a pump, an elbow, a half open valve, whatever it is, chemigation valve, you'd want 20 inches. Then on the downstream side, you'd want 1 pipe diameter, which is 10 inches. And that's an ideal installation, and that is accounting for any type of variable you could have on either side. When you look at mechanical meters, like your propeller style flow meters, a basic propeller meter would require 10 pipe diameters upstream. So on a 10-inch pipe, you need 100 inches upstream and 5 diameters downstream, so 50 inches on the downstream side. Now there's straightening vanes, there's wafer cones. There's different types of things you can do to put in front of those propeller meters to shrink that straight run requirement down. And it typically reduces it down to half on the upstream, and I don't think it reduces it down on the downstream. I think what you end up with is instead of 10 on the upstream, it's 5 on the upstream, but you still need the 5 on the downstream. The reason why it's critical to install the meter with enough upstream, downstream, it all has to do with the velocity, the swirl going through that line. You want to make sure you're getting a good flow profile going through the line. It is extremely critical on mechanical meters that they are installed with the proper upstream, downstream. On magnetic flow meters, there's a lot of test data out there. I know we have it. Our meter's been tested by Cal Poly San Luis Obispo. It's been to Utah State Water Research Lab. We have third-party reports where they'll take a full-bore mag meter and with no straight run, they'll butt it up against a chemigation check on one end and maybe an elbow on the other. And our meter has come in within the specified accuracy every time. Although in our manuals, we will still recommend the 2-in-1 because we have to compensate for any type of possible installation that could come up down the road. On mechanical meters, there's typically no leeway there. You've got to have that straight run to get some of that swirl out of your flow comes through an elbow and it's swirling. It's got to be straightened out. So you can use flow straighteners, you can use wafer cones, whatever that meter manufacturer has to help take the swirl out of the water. But it's critical you follow those instructions or you're not going to have an accurate meter. You might get a reading on it. That dial might be moving around and spinning around, but it's not going to be an accurate reading. Typically, flow meters require a full pipe of water as well to perform correctly. So mechanical meters, how do they work? They're pretty simple. There's either a paddle wheel or a turbine that spins as the water's flowing through the line. There's like on the propeller meters, you know, they're cable driven. A lot of them are cable driven. Some are gear driven. There's a drive cable like on older cars. It's literally a drive cable that engages into the propeller up into the register. And the register kind of reminds me of an odometer and speedometer on an older vehicle. It's mechanical. Sometimes they have pulse output in them. They have some type of an output in them. But again, it's moving parts that is causing some type of effect in that meter, depending on what meter it is, to give you a reading on them. Here's a popular propeller meter down here on the right-hand side. And this is just kind of an image that shows us what I'm talking about with the flow profile. As the water's coming through that elbow, it's moving pretty fast and it's swirling. It's causing that register to read high. So if your mechanical meter is installed without the proper upstream pipe diameter, it's going to cause you to read high, which isn't good because it's going to say you're using more water than you think you're using. Magnetic meters have been around a long time. They didn't really start becoming popular in the irrigation market until probably the late 1990s. They've been popular in the industrial municipal market for many years. They all utilize the same principles. It goes back to this gentleman, Michael Faraday. This is electromagnetic law of induction. Because in the irrigation world, there's a lot of times not power out at the site where the meter's being installed. I know sometimes there is, but a lot of times there's not. These are very rural locations where we're putting a meter in. And in the old days, magnetic flow meters required power in order to operate. And a lot of magnetic meters still do require power to operate. But sometime in the late 1990s, manufacturers started trying battery-powered mag meters. And, you know, through trial and error and power consumption and whatnot, they've pretty much nailed the design on battery-powered magnetic flow meters. You'll see them start becoming more and more popular. The one that's sitting out here on the table has a minimum 5-year battery life. That's our latest release of a meter here. So there's no moving parts in that meter at all to wear out. And so this is essentially how they work. There's electrical coils outside the flow, those are energized. Magnetic field crosses the flow. It's reading the conductivity in the fluid that's going through it. So mag meters work very, very well on well water, on dirty water. They wouldn't work on something like deionized water. They need those minerals running through the water. That's what they're measuring. There's electrodes inside the meter, and I welcome any of you to walk up and look at the meter if you'd like to see what they look like, little stainless steel buttons in the meter. And those electrodes are measuring the change in voltage as the fluid's flowing through it. And then you end up getting your rate and total, comes out on the screen. This kind of shows you what's going on inside the pipe. This principle of how mag meters work applies to all manufacturer mag meters, all types of mag meters. It's a little bit different when it's an insertion mag meter. There might be one magnet in it instead of several electrodes, but the principle is still the same of how it's working. Okay, so when we look at all the different options of flow meters out there, insertion, full bore, mechanical, electromagnetic, the trend that we're seeing over the last several years is a trend of people starting to need meters that are highly accurate over a long period of time. They don't require annual calibration on them to ensure that they're still within the manufacturer's specified accuracy range. And they don't require a lot of maintenance. We're seeing a trend of people moving to electromagnetic technology, and also ultrasonic technology is starting to become more and more popular as well. So electromagnetic meters are highly accurate. They're typically plus or minus 1% accurate, versus you start with a propeller meter at plus or minus 2% accurate. As you get into other types of mechanical meters and insertion style meters, your accuracy starts dropping off from there. But a full bore electromagnetic meter, I think most of them on the market for the irrigation market are within the 1% accuracy range. The other thing is with magnetic flow meters, they typically come with a lot of features on them that you may use today, you may not use today, you might use them later. But they come with things like a pulse output. A lot of them come with a data logger built into them, bidirectional flow reading. So you'll have forward flow, it's constantly accumulating forward flow. If flow runs in reverse, it'll capture that information as well. They have pulse output in it. If you need it, great. If you don't, it's there if you want to hook it up years later. With mechanical meters, the way that I describe mechanical meters is it reminds me if you go to a restaurant and you're ordering your meal. You order a combination plate or you order off the a la carte menu. So with mechanical meters, you can get a very basic meter. It has a mechanical head on it, rate and total, and that's it. But if you need straightening vanes, if you need a pulse output, if you have a higher than normal flow rate and you have to put a different type of a bearing assembly on it, and you start adding all those options up, 400, 300, 200, you're pretty much at the price of a full bore mag meter. When you look at overall cost of ownership on that meter, mag meters do not have moving parts to wear out in them. So at about the 4.5-year range, you would get a low battery indicator light that would come on. You go, oh, I need to replace the battery pack in this pretty soon. There are occasions where there's a lot of sediment, mineral buildup in the water, and there could be times when that meter would have to be removed from line and you take a cloth and clean the little electrodes off and put it back in line. But that's it. Mag meters are going to remain accurate versus mechanical moving parts meters, they wear out. So even though the dial might look like it's working properly, there's a good chance, unless that meter's been maintained at least every season, that there's the complete chemical compatibility. Doesn't matter what's running through the water because there's no parts, wetted parts it's going to touch. So we're going to start seeing more and more ultrasonic meters break into the irrigation market. And again, that technology is relatively expensive today, but as it becomes more and more popular, that price point will start dropping down as well. We did bring an ultrasonic meter here. Doesn't look like a meter at all, but this is actually a meter. These are the electrodes. It sets on a pipe, and these straps are so long because it works on, is it 20, up to 20-inch pipe. 1 meter, 2 to 20-inch pipe. This one's meant to be a portable verification tool is what this one is. This isn't meant to mount in line permanently. This is a portable verification tool meter. But this is an example of an ultrasonic meter. What's kind of cool about that meter is it's so simple even I can use it. Ultrasonic meters are typically, somebody needs to be pretty highly trained in order to use an ultrasonic meter. This one works via Bluetooth technology, and your Apple device or your Android phone becomes your register. You download a free app on the internet called the JWave app, and it just walks you through a series of questions, and you can be up and running and reading how much water is flowing through that pipe within a matter of minutes. And because it operates via Bluetooth technology, let's say you had 15 meters that you're managing, 15 different wells. It'll remember those GPS coordinates next time you drive out to it. So next time you go up to it, you don't have to re-input the media, it's media, pipe size, pipe type. There's drop-down menus, schedule 40 PVC, water, ambient temperature. You hit go, and you instantaneously you have your flow reading through your pipe. So it's a great tool too for figuring out how much water is flowing, what size of a meter do I need to order for a permanent install meter. This is it, the JWave. That just shows it mounted on a piece of pipe. Got ahead of myself.
What is the cost of that?
I'm sorry?
What's the cost?
This is, it's $3,500. And typically it's not a huge, a district will order 1 or 2. These are districts that, you know, manage multiple metering points. It comes in a carrying case, and it comes with the charge cords and everything with it. So that's the whole kit price.
You have to have a power source?
This one, it has a 12-hour battery charge on it. So it does have to be charged up. It's truly meant to be a portable meter. It's not, at this time, Seametrics doesn't offer a permanent install ultrasonic for irrigation. That's our only ultrasonic, but it's truly meant to be portable. We saw a need for people that, not just on our meters, but on any meters they have installed, they needed a way to verify annual calibration on them, or they needed a tool rather than taking the meter out of line and shipping it to the manufacturer to be calibrated every year. They needed a way to verify that the meter is still operating within the specified accuracy range. And so this product will do that. This will satisfy most districts' needs. As a matter of fact, it's irrigation districts that are mostly in large scale farms that we've seen a demand for those.
You can run it off that charge cord too if you want to just plug it in, but then you've got the charge cord sitting out there. I wouldn't leave it there for season, but if you wanted a data log for a week or something like that.
That's a good point, because we just added data logging feature into it. So this one happens to be a transit time, because there's different types of ultrasonic meters. This one happens to be transit time. This just explains the inputs to how a transit time meter is working. So temperature, density, viscosity. And again, when that app is downloaded, anybody's welcome to download that app. You don't have to have a meter. It's kind of a neat app. It's just JWave app on Google Apps. And you'll see in the drop-down menu, there's different medias in there like milk and diesel fuel. That's because we sell into other markets. So we've sold these products into food and beverage in different markets. But clean water is certainly on there. On the irrigation app, it'll take you through the drop-down menu, which is the most common pipe sizes in irrigation. I believe we have all of the pivot manufacturer pipe types in there. And then there's steel and aluminum and PVC. It's kind of a neat product. Again, this one's portable. It's plus or minus 2% accurate. So if you have any of those propeller meters or mechanical meters out there, those are plus or minus 2% accurate. It's typically the manufacturer spec on them. This would be a great tool to stick in line and compare the accuracies. This just explains what, if you guys are interested or you want any more info on it, you can come talk to Paul or I, or you could check our website. This just explains what the different components are. Very easy to use. That's what I like about it. This is the AG3000 meter. It's our latest full bore mag meter. It's Seametrics has had a full bore mag meter in the irrigation market since the 90s, and it has evolved into a product that has a very long battery life, a lot of built-in features and different options. The most common one's over to the left, which is going to give you rate, total, pulse, bidirectional flow. It's IP68 rated. Should it be in an area in the field that ever gets flooded, you're not going to have any moisture intrusion. You can get data logging on it for a very small adder. It is available in a P premium version, which drops the accuracy down to 0.75%. I think on the P version, you can then get, you can get Modbus on the regular version, right?
You can,
Yeah, on the regular version, okay. The P and the R version, those aren't going to be as common in ag. We more took our industrial municipal meter, made it available in case people wanted more options. The R version is a good one to know about. It's a remote mount register if anybody has the need for a remote read meter. This meter has a 5-year battery life. It's plus or minus 1% accurate on the standard version. The P version has a 0.75% accuracy. This one's really a neat meter because on the dial face, it's super easy to use. Everything, if you had ordered this meter in gallons per minute, and then you wanted to set it up in acre inches by gallons per minute or cubic feet by cubic feet per second, it can all be done right at the head there. Pulse output changes can be done. It's password protected. You can't reset the total ever, but it'll convert your total over to whatever units of measure that you've changed it to. Built-in battery, built-in data logger, has batching capability in it. We had that request from certain customers. Installs in tight spaces, and we're proud to say it's manufactured in the USA. We manufacture these meters right down in Kent, Washington, just outside of Seattle. Here's a couple, Paul, look, you're famous, your picture's in there. These are a couple of installs Paul and I oversaw in Idaho recently. So you can see it's installed in pretty tight spaces. The picture on the right, that's an elbow going down on the ground right on the other side of where the dog's at. And so these will give them plus or minus 1% reading in those tight installs. The main benefits of full bore mag meters are they install in cramped piping, very tight spaces, minimal straight run. You don't have any bearing assemblies, no parts in them to wear out. You know they're going to maintain their accuracy when you put them in because there's nothing to wear out in them. Built-in pulse output at no additional charge. Our pulse output and our Modbus output have been tested with a number of remote telemetry companies, and I'll touch on that in a minute. They're more accurate than insertion meters or mechanical meters. They're just a rugged meter, and they're accurate over a wide range of fluid velocity. When you look at mechanical flow meters, they typically require a minimum flow rate flowing through that water to get that mechanical component turning fast enough to get an accurate reading. So a lot of times you look at a manufacturer specification and it'll say on a, let's say on an 8-inch meter that it will require 100 GPM minimum, just to get the prop turning so that you get some sort of reading on the meter. With mag meters, you remove that element of moving parts. So these things will, as long as you have a full pipe of water, they will they'll start reading right away, very, very low flow, very low flow. And they'll read up to extremely high flow rates for that same reason. There's no moving parts in them. So they're accurate over a wide range of fluid velocity, which is another advantage of them. We look at accuracy and calibration. We're seeing more and more and more that districts, whatever governing agency, or even if it's a large scale farm, and even if it's a grower that's just wanting to make sure I've spent all this money on my farm implementing irrigation best management practices, is everything working correctly? You know, some of you might have soil moisture sensors, you might have weather stations, you've invested a lot of money on your farm. Is everything working properly? And a lot of times that flow meter is used as a tool to know, are there any leaks in my system? Is there anything gone wrong? So it's important the flow meter is working properly. You can't manage what you don't measure, and the data is only as good as the product's performance. So meters can be sent in. There's some third-party people that'll do calibration. Typically, a manufacturer will do a calibration. How often that's done, usually every manufacturer has their own recommendations in their manuals of how often you should do it. Sometimes that recommendation comes down at the district level where they'll say, we want to see that your meter is calibrated annually. I think a good thing to make sure of is that the calibration is always NIST traceable. What that means is National Institute of Technology Standards. That means that whoever's calibrating your meter, their equipment has been tested and certified to a certain standard. So you know when you get your meter back, it's as accurate as they say it is. NIST traceable is what they call it, if you're sending it out somewhere to be calibrated. Otherwise, if it's acceptable, there's portable devices. This isn't the only one. There's a lot of manufacturers that make portable ultrasonic meters to test the accuracy of use it as a verification device. Remote meter reading, AMR, automatic metering, been around many, many years with housing meters. Probably most of us, that's how our meters have been read for a number of years. It is now becoming more and more common in the world of irrigation. It's being referred to right now as remote meter reading. It's one input on the field. So you're looking at people, some people have, maybe not in this room, but we see a lot of people center pivot irrigating, and they're able to install a remote telemetry system that'll let them move that center pivot around their field off their phone. It's amazing what you can do anymore. You can control things on the field with your phone or your iPad. The meter is one input from the field, and we are getting more and more requests for, can we read the meter remotely? And how do we do that? And it's as simple as a device. You've got a device, and we're showing you one option over to the left side. That data goes up into the cloud, it comes down onto your screen, and you get your data, your rate, your total. You can set up alarm parameters. If pressure drops off in your system or your flow rate drops down to a certain range, you can have an alarm go off where you get a text message, you get a phone call, you get an email, whatever that is. This technology is becoming so common. I was at the World Ag Expo show in Tulare last week, and there are dozens and dozens of telemetry companies that are doing this. And we've been working closely with a number of them to ensure that our meters are compatible with a number of systems. At this time, we don't offer a telemetry system per se, but the pulse output, or let's say the Modbus output, we're seeing Modbus is becoming, it's a cleaner communication protocol. Whatever that meter is reading at that given time, Modbus will give that direct communication across the cloud, and that's the data that you're gonna get. There's no lapse in time like there is with pulse output. Our meters were on display last week with Ranch Systems, Observant Wild Eye. Those were a few of them that had them tied in their booths, simulating what that would look like. So You can read meters remotely, yes. Even if you have an old-fashioned propeller meter out there, an old-fashioned mechanical meter out there, you can get remote technology on it. You call that meter manufacturer up, let them know what you want to do. Typically what they'll do is they'll sell you a transmitter, pulse output transmitter that you would mount under the register on that meter. And then you want to make sure that that pulse signal is going to be compatible with whatever manufacturer you're looking at partnering with. So it's pretty amazing, but it doesn't matter how old your meter is, what brand it is, what technology it is, you can read those remotely now. A little bit about what Seametrics offers. We, the only mechanical meter really we sell it to ag is the Paddlewheel meter. Our expertise is electromagnetic meters. That's really what we're known for, is no moving part, battery powered meters. We do have insertion style, and we have the full bore style down to 0.5% accuracy. They're NIST traceable at our plant down in Kent. We have low voltage DC designs. If you have a power source there and you want to hook power up, you never have to replace the battery. They're easy to install, easy to operate, and they come standard with a 2-year warranty. One thing I love about Seametrics is we stand behind our products. We care about our customers, and we frequently will flex outside of that warranty if we need to take care of somebody. That's all I have. Does anybody have any questions? Yes, sir.
I have a engineer question, maybe. You know, on my phone, I can look up and I can go to how much I have for that call and for maybe that month, and then I can have lifetime. And I know with the Seametrics, and I have several of them on our farm, is I only have the option of looking at what I'm using right now and my lifetime. What would be helpful to me is if I could either reset by season or by month, so I would know how much I would do for that season. And I mean, I can obviously data log it, but it would just be nice if it was programmable that I could do that in the system.
This new meter, it has a net, a forward total, a reverse total, and a net total that are not resettable, and then it has a batch total, and what did I say, a forward and reverse, and a batch forward and a batch reverse that are resettable, just right there on the panel.
So you would use the batch one. Unfortunately, you probably have the AG.
Chemical installs, and so I have the Seametrics with the K factor and the pulses, so I'm kind of stuck with what he puts in, but for most of it. But it's just, you know, I have the instant and the lifetime, and that's my two that I have.
Sure, let's take a look at this one, you know, and yields. I think you'll like what you see with this.
And they used to be that they were just, you wouldn't have to plug them in. Now my Seametrics require a power source.
Are you in Idaho?
No, I'm here local.
CH2O or?
No, it's West Office.
West Side.
Allen Shaw with Westmont.
You should be able to, with just pulse out, you should be able to run off battery. The meter will run off battery.
Well, it may be local. We used to just have the meter in the, and there, and it shows the display. Now he has to plug into my 110 in order to be able to do all the pulsing and everything that he needs to do to get the right chemical dose.
Maybe we can exchange contact info
Yeah.
and get your serial numbers off your meters, and we can look up the records and see if there's something unique with those meters.
It might be something that he's doing with there that he needs a little more information or something to that effect.
Okay. We're using LMI pumps.
Yeah, it shouldn't really. It's the pulse out should be able to, or your meter should be able to pulse out. Oh, you know what he might be doing is he might be needing a high enough pulse out frequency that we told him to plug it in so he doesn't run the battery down. The new meter does have a longer battery life, probably twice or 3 times as long as the old one did.
But he needs the extra power for the higher pulses.
He did with the 2000, with the AG 3000, he may not. He won't need it to function. You might need it for the battery life.
I don't know. He takes care of it. So
Yeah,
it's
yeah,
just kind of,
yeah. And you probably haven't seen the 3000 because it's relatively new. He might have, but I think once he looks at the power consumption, he'll find that he will be easy to be able to get a season out of each battery, even at highest also.
Will the A3000 also be available on the industrial side?
Yeah, it's called
It is, the iMag.
Same meter?
It's branded different. It's a little bit different, but it looks very similar.
It's not the same.
The iMag has more features in it, such as heart. It has 4 to 20, be more common. So what we did with the AG version is it's a version of the iMag. The iMag was rolled out into the industrial municipal market and the fracking market. Fracking's so hard on our meters. Toss them in a truck, they bounce around, they install them for a few days, they take them out of line again. That was our iMag. So that was kind of our test meter. Make sure it was durable. I know the irrigation market, you guys want durable, long lasting, and we didn't want to have any bumps in the road. So at which point we took our iMag and we scaled some of the features out of the base meter to get it down to the price point that the irrigation market will bear. So you guys don't typically need stuff like heart protocol and 4 to 20 milliamp. And there's certain things that are common on the industrial muni side. You can get them, you can add them onto this one and get that P version I showed. But for this base meter, it's rate, total, pulse, and then the next most common thing is data logging. But when you look at the meters visually, they look very similar. The iMag has is it a blue or a black ring? Yeah, but they look very similar. The price is higher on the iMag. It's for that.
When you brought the egg price down to eliminating some of the features.
Yes,
you don't necessarily-
yes.
Think about almost anything that you need that is available on the 3000.
Did you have any questions?
I was just going to ask if, do you feel the mechanical meters, insertion meters are kind of going the way of the buggy? I mean,
I think they're okay products. I think they're okay products. I'm not gonna put them down. It's just that they're okay products. It's just, I think that there's a perception that as long as the dial's moving around, the meter's working. And it's a false perception that people have because there's a lot of times the meter's not working properly. And just because something's moving, and battery powered mag meters, they get kind of a bad image out there because if you don't change the battery in it and it goes dead, the screen's blank. Now there's no false perception there. It is not working, right? With mechanical meters, people seem to think, I've heard districts say it before, these guys that have had them for years. It's been working for 30 years. We've never rebuilt it. Squeak, squeak, squeak. I mean, you can hear the thing, right? And so it's just that it's a supply demand thing. I mean, there's a lot of mag meter manufacturers now that used to focus on industrial municipal. They see a demand for it in irrigation. It's driving the cost down on them. So I encourage people when you're looking at technologies to just keep that in mind and forward think that do you just need rate total or is there anything else you want? Do you want a data log? Do you want an output to tie into something? Then price shop them. Because I think what you'll find is these mechanical meters, year after year, they take price increases. Year after year after year. Mag meters, not so much. We'll go years without a price increase on mag meters. So that gap on pricing is really closed in. But I'm not going to say mechanical meters, they're fine for a lot of people. Anyone else? Thank you all for your time.
Thank you.